All right. All right, so let me give you the cases for when we need to use law of sines. So remember, you can no longer use Pythagorean theorem because that is only for right triangles. So let me give you four cases where you need four cases where you have non, right triangles, just regular triangles, general type. So here is case one. One side and two angles are known. So basically, as long as we have a side in any of the angles, as long as you have two of them, you have case one. So that's going to be ASA, SAA. Okay. Sorry about that. Someone's spamming me. All right, case two. Two sides. And an angle opposite to one side. So basically, if you have two sides, you gotta have one angle opposite to it. Okay. Otherwise, you can't use law of sines. So if it's one of these, side angle, then you're good. You can use law of sines. If you do not, then you have to use law of cosines, which we'll talk about in the next section. Case 3 and 4 are law of cosines. Two sides and the included are known. Hold on a second, that doesn't sound right. Included angle. All right, case 4. Oh, geez. Give me one moment. And case 4 is when you have three sides and no angles. So then this entire section 9.1 and 9.2, or sorry, 8.1 and 8.2, are just about finding angles and finding sides. So very visual, very problem solving type of thing. Okay. All right, so here's the law of sines. So for a triangle, with sides ABC, and I'm really bad at capital letters here apparently. So I'm going to try my best to distinguish capital C and lowercase c from the book. And opposite angles. Capital A, B, C, respectively. So here's my attempt to draw a triangle here. So it's not a right triangle, could be one of these, could be something else, whatever. So angle A, B, C, and the opposites are here, here, and here. Okay. That makes sense. Oh, they said respectively, right? So A is there, B is there, etc. Little c and capital C. Okay. So here are the formulas that you need to use. You can use them in either way. You can have it this set up this way. You can equate any of these three equal to one or the other. Doesn't matter. They are all equal to one another. You can also take the reciprocal of all of them and they would still be equal. Sometimes I choose these just because it's easier. Trying to get out of that little glare there. Easier to solve for, let's say I want to solve for A, it's already on top. Well then, cool. One last step. Okay. All right, let me find an example. Pick one from the notes here, and then I'll pick some from the homework, I guess. So solve the triangle. Okay, let me pick one here. They don't always going to give you a picture. Like sometimes they will, sometimes they won't, whatever. And their pictures will be prettier if they do. So let's say I have an angle of 100 degrees here. Over here we have 60. I don't have this angle. I have this side over here. We'll call that 4 to remain consistent with the, what's it called? The formula. Okay, so what I like to do is write down all the stuff I do know. So capital A, I do not know. B is, we put B here. So we do know A, sorry. C is 100. Yeah. Okay, now the sides, we don't know. I'm going to go ahead and label this because I'm going to confuse myself otherwise. Little a is right there. Don't know it. Don't know little b. I do know c to be 4. Okay, so we haven't started. We're just writing stuff down. So the question becomes like, which formula do I use? And which thing do I try to solve for first? So the easiest thing to find is that angle B, right? Do you see that?
Don't all triangles equal 180 degrees?
Yeah, exactly. So we can use that fact, right? So if the total is 180, what does B have to be? Angle B.
20 degrees.
Yeah, so this is almost given to us. And if we don't see that, we get 180 and subtract by 100, subtract by 60. The leftover is 20. Any questions about that? Okay, so if we didn't have that or whatever, you want to choose, so if I want to choose to find A or B, you want to choose one where you have the angle already found. Like if both of these are missing, you probably don't want to go for this one right away, right? You might want to find the angles first. Okay, like we did here. These were both missing at first and we found B, so now finding these two will be straightforward. So I'm going to choose the second form because it'll be easy to solve for A algebraically, right? Ouch. Biscuit. So A over sine A is equal to, so I can equate it to any of them. I'm going to use this one here because it has both parts. So see how I'm choosing to solve for A. So start with this side, and I'm going to use these two. So set equal to this one because I have both parts. Because if I have too many unknowns, and I can't solve for one variable, right? You know what? I'll leave that blank because we originally didn't know that. Okay. So how do we solve for A? Little a.
First solve for the sine of A and the sine of C.
Like I want to get little a by itself, right? So this is in the way, right? The sine A.
So multiply each side by sine over A.
Yeah, exactly. Multiply both sides by sine A. Sorry, someone's popping fireworks outside. Distracted me. So both sides by sine A. So these are canceled. So A is equal to C sine A over sine C. Is that algebra clear? I solve for little a. So then just plug in all the numbers and we're good, right? So that will be 4 sine 60 over sine 100. So now this entire chapter is going to be very calculator heavy. Just gotta plug it in. $3.52. Let's see. Yeah, that's right. Cool. So we found little a. So I'll do the same thing with b. So I don't think I have space here. So we'll do it on the back, I guess. Maybe I could put it here. B over sine B equal to, I'll use the same one, C over sine C. So solve for little b. So this time I'll skip the algebra. So b is equal to C sine B over sine C, which will be 4 sine 20 over sine 100, which is about, did you guys get 1.39? Cool. So you see the main idea, right? We're just using these formulas in whatever way we want to find the missing sides. Obviously, this triangle is not to scale because these measurements are quite different. This makes it look like they're all equal, and they're not. You guys cool on number one?
Yes, sir.
Okay. Cool. That makes me feel better. I feel like maybe it's not too bad then. All right, let's do another one. Okay. Yeah, maybe this time I'll pick one.
This is 8.1.
What's up?
So you wrote 9.2, but you're trying to like for when you post this later. This is 8.1. Nope. Other page.
Yeah, you're right. You're
Where
right.
you wrote.
Yeah, earlier I put 8.1. You're right. I'll get used to the new book eventually. Okay.
And
So
they'll change it again.
yeah, probably. Yeah, they do that. Let's see here. So I think eventually I'm just gonna write a title and not care where the section is from. Just quote topics. All right, so the last example, let's go before we move on. Something I need to mention. We knew that there was one triangle because I gave you a picture, obviously, but also because I gave you two angles. So in a problem, if you are given two angles, then you are guaranteed one triangle. If the problem only gives you one angle, there's a possibility that there will be one triangle, two triangles, or no triangles. So we'll do all those scenarios in just a moment. Does that make sense what I'm saying? You try to find a picture. I forgot. Currently don't have a keyboard. 1 second. Why they're pumping so many fireworks right now? Jeez. You guys hear that?
Yeah.
People be partying hard.
Guess so, man. Happy end of Halloween, maybe? I don't know. I don't know what's going on. See,
Day of the Dead?
maybe, yeah.
Could be Day of the Dead.
Was that today or yesterday? Yesterday.
I thought Day of the Dead was like it's only one day, but the partying goes on for like a week or something.
I don't remember. Could be right. Okay. Now here's a random example. So when using law of sines, can you see this? So let's say we were solving for this triangle, right? So we may have multiple, I think they called this, what was their original set? A, B, C. Okay, so A, B, C here. So this one has two different B's. So this side here can either flip inward, creating a shorter side, or a different angle here, or flip outward and create a different angle here. You see what I'm saying? So this B could be two different angles. This is what they mean by there's two triangles, okay? So the one we have to change or solve for is going to be this angle and this angle, but also this angle here and this angle there also change. So we're going to have ABC and then maybe an A1 and a C1 or a A2 and a C2 or whatever. Some of them might be the same. Like you can see here how this side was still 40, even though it flipped outward. The only thing that changed was the angle. It just swept this way or that way. This side did not change. There's a 52 no matter what. The only thing that really changed was the C, because I'm closing it off here, meaning it's only this long, right? But close it out here. And here's the two scenarios separated. Maybe this is more clear. So if I go inward, this side has changed, right? This angle has changed. If I go outward, this angle and that angle has changed, right? But the 52 and the 40 are the same still. So this is the case where you have two triangles. So some things remain the same, some things are fixed, but some of the angles will have two solutions. Okay, so usually the given angle will be fixed, but the ones you solve for will have two sets. Okay, if there is two triangles. Okay, does that make sense what I'm trying to say? Trying to make sure you see the picture.
I'm
before we
sorry.
start.
Say it again. My dog was like distracting me. I didn't hear you.
No, it's fine. So in just a moment, what we're gonna do, so this is actually a good example. We'll solve something like this in just a moment. So notice how here they say solve the triangle, right? They give us a capital A, but no other angles. So this is a possible problem that may have two triangles or no triangles, or just one. It depends. They give us two sides. As long as one of the sides is opposite to the angle they gave us, then we are allowed to use law of sines. So here, they go ahead and do the nonsense, which we'll do together in a moment. And then they solve for B. They isolate sine B, and then they use the inverse sine of both sides. Who cares? We'll talk about that in a second. Once you find that angle, you'll have to subtract from 180 degrees to find the other angle, which is also called the reference angle. So the reference angle of 53.2 or of this one is that guy. Okay, so this angle and that angle, there is a B1 and a B2. And this is the scenario here visually. So the angle, if we use the 126.8, then that means that the angle is closing this way. If we use the other angle, then it sweeps outward to 53.2. So this side of 40 either goes in or out. So this is the two triangles. So when I move this side though, inward or outward, then that changes this angle, obviously, and the angle C. So they'll have two different C's. So when you solve for C, you have to do the same thing. You have two different sets. So this problem right here has two sets to solve for, but notice how some of them are fixed. 52, 40, 52, 40. The original angle, of course, is fixed. So that's what we're going to do in just a moment. So I just want to make sure you know what I'm talking about when I say it could be no triangle, 2 or 1. This is what I'm saying. Okay. No triangle looks like this. It just never closes. Something like that. It's not long enough. So this happens when you're trying to solve for an angle and it turns out you get an error in your calculator. Usually that's a big red flag that, you know what, there's no triangle. Okay, and then I'll show you how to tell if there's two. Having two sucks because it's more work. Having no triangle is the best situation because you're done and you move on to the next question. One triangle is okay, I guess. It'll be similar to what we did in the last problem. Okay, so let's do a question. Then I give you a brief rundown of what we're gonna do. Okay. Oh yeah, that's fine. Two sides. And an angle are given. Determine if the given information results in 1, 2, or no triangles. Okay. So this time I'm just going to give you the information. I'm going to draw anything. I'm not going to draw anything. Just I'm giving you the B, angle B. I'm not giving you any other sides. I'm giving you little b. Let's see here. Yeah, 7. Little c is going to be 5. So notice how we have two sides and one angle. So this is the scenario that can create this multiple triangle problem. Okay. So before we start, if you were doing this on your own, what angle would you solve for first?
See?
Yeah, we should find C first because we have that side. So that'll be easier to find. And once we find C, then we can find A, no problem, because we know the total of the 3 angles, right? We cannot find little a currently because we do not have this angle. So we have to go start. We have to start here. There's no choice. Does that make sense, thought process? So I'm going to equate this guy to the complete set, B and little b, here. All right, so how do we solve for sine C? What would you guys recommend doing first?
Get big C alone.
Yeah, for sure, right? We gotta get this big C alone. But currently we have little c in the way, right? I promise this is capital.
Multiply both sides by little c.
Yeah, let's do it. So both sides by little c. You could technically do this with numbers, but I like to solve in general and then plug the numbers later. That way, who cares? We're done. That looks weird. Can you write this better? So then we get sine C equal to C sine B over little b. So now we got to get rid of that sine function. How do we get rid of sine?
Is that
Isn't
sine?
that the end function?
What's that?
So isn't that the inverse function?
Yeah, we'll have to use the inverse function to cancel sine. So sine inverse of both sides to solve for C. So this side looks disturbing, but oh well. So that implies that C, capital C, yeah, is equal to sorry, lost my train of thought there. Sine of
Wait,
sine
so
of, sine of
where's the negative?
I forgot to write it. C sine B over little b, right? Okay, so C, so plug in all the numbers, that will be 5 sine of 140 over b 7. So what is that going to be? Ouch. Seven. Okay. I should be in degrees. Let's check. I am not. Okay, so 27.33. So round to 2 decimal places. Okay, so this is the, so all this makes sense so far, right? Before we get to the next part.
Yeah, this algebra is easy to understand.
Okay, cool. Stop me at any time if something's weird. So I guess to help you understand this part, let me pull out the circle. I don't know what the hell is that thing. Mhm, mhm. Okay, here we go. All right, so remember how I told you sine inverse is the range is defined out here from the negative pi over 2 to pi over 2. It does not go over here. So if you use the calculator and function for sine inverse, we're only going to get stuff from 0 to 90 degrees or 0 to negative 90 degrees. Nothing else will appear. But you can see that there are, let's say I was trying to do sine inverse of 1/2, right? There's two locations. There's a 30-degree solution, which the calculator would give, right? Let's do that really quick. Let's pretend. So second sine inverse of 1/2 is 30 degrees, right? That's what the unit circle said, and that's what the calculator says. But it does not give me, this other solution. So remember how we said we had to do 180 minus that answer when we were doing the equations, I think. So that use the reference angle. So the reference angle of this solution is 30, right? So 180 minus this solution will give me the other answer. Meaning the answer that I found that's not pretty at all, the 27 point whatever, we'll have to subtract from 180. Okay, so we have a C1 equal to this, and a possible C2 of 180 minus 27.33, which is something.
I'm sorry, sir. Why do you have a possible two angles?
Because when you use sine inverse, there are usually two solutions for a value like this. See how we plug that in there? So there's two locations that give me this number. One of them is 27.33, the other one is 152.67. So the question is, do both of these angles work? And if they do, then we have two triangles. So we got to test now. Are these both viable angles? Does it work?
So why does the inverse result in two different possible answers?
Because there's two places where that is true. So let's check this out. Remember how that's what I was saying, right? The sine function has two places where we have a 1/2 and a 1/2, right?
Huh. Okay.
So that means there's two solutions for the equation sine theta equal to 1/2. It would be 30 degrees and 150 degrees. So our angle is not on the circle, but that doesn't mean it does. That does not mean it doesn't have a pair. So we have to find its pair and check if it is a solution for this particular triangle. Does that make sense?
Not entirely, but I'll ask you about it more later.
Yeah, just remember this, right? There's two places where you have a 1/2, right?
Yeah.
So there's two places where this weird shit happens, whatever that is. So this is just some number like, I don't know, 0.78 or something, right?
Would it be accurate to say that sine inverse always results in two answers?
The equation
Is that a fair thing?
sine theta equal to some value, sure, but
I mean, sine inverse.
so this question here is what we're asking, right? Could be any number, I don't care what it is. So sine theta equals some number. We'll always have two solutions for theta. So when you use the inverse, you will only get one, but you can find the other one using the reference angle.
Okay.
Okay, so that's what I was saying, like if you were to use a specific example of some tan theta equal to 1/2, there will be two places.
Yeah.
So to solve that, you would do, right, sine inverse, right, of both sides. Then you'd end up with theta equal to 30 degrees, right?
Yeah.
So there's still a second one. And so we must subtract from 180 degrees to get the second one.
Okay.
So that's what we're doing here. So this question, sine C equal to this number, has two answers, two C's. And that's how we find them, like this.
Okay. Thank you.
Yeah. So once we find them, we got to check, okay, is it a legit answer? Like, does it work? Because remember, triangles must add up to 180, right?
Yeah.
And if it doesn't, well, it's not a triangle. So if they both exceed 180, then it is not, then one of those may not be a solution. So what you do, so let's check this out. Angle B is 140 degrees, right? So do you agree that B plus C1 is less than 180?
Yes, because all triangles have to be 180.
Right? Well, I mean, we have to look at it, right? 140 degrees plus 27. For sure, that's not over 180. That's 167.33, right? So cool. So now, what about the other one? Is B plus C2 less than 180?
No.
No, right? 140 degrees plus 152, that's pretty big. It's like 290 something, right? So that means that C2 is now a solution. Okay, so since, put this in English, since B plus C2, which is equal to 140 plus 152.67 is greater than 180, then we only have one triangle. That's how you check. So we don't have to worry about two. Now we'll just solve it like normal. We'll just move on. So if we have these, what is capital A? $12.6. Yeah, sounds right. Okay, so does that make sense? How you check?
Yes, sir.
Okay, so now we'll just find little a and we're done. So A over sine A is equal to, I'll use the B just because they're more exact. So solve for little a. So A will be equal to B sine A over sine B, which is equal to 7 sine 12.67 over sine of 140. So it's about 2.39. And we're done. So we found all the sides, so there's only one triangle. That's it.
Wait, sir, what is that number? 7 sine 1 something.
12.67.
Where did we get that?
Oh, that's angle A.
Oh, okay.
We did that by subtracting from 180, right?
Gotcha. Just checking.
Any questions on this problem?
No, sir.
Yes. You guys cool on this page? Okay. All right. Right now, let's do one where there is two triangles. Meaning you find C1 and C2 and they both work, meaning you're going to have to solve two sets of triangles. Two sides and an angle are given. Determine if the given information results in 1, 2, or no triangles. All right. This is all they're going to give us. Similar to the last one. Okay. So we're going to find C the same way we did last time. So a very similar question. At least it starts off the same. So sine C over C will be equal to sine B over B. Isolate sine C, so that'll be sine C equal to C sine B over little b, which implies that C is equal to sine inverse. I skipped a few steps. Let me know if you need me to go back for the algebra. So that will be sine inverse of 11 sine 20 over 9, right? So that is approximately. Is that 24 degrees around there? Let me see. $24.71, I guess. Yeah, that's right. Okay, so we're going to have a C1, an A1, and a little A1. So we're gonna have another set here. A2, B will stay the same. C2, this will stay the same. A1, C will stay the same. Yes, okay. All right, so remember how we said, once you find the C1, you subtract from 180, right? So C2 is equal to 180 minus 24.71 degrees. Which is 155.29 degrees. So this is the other angle. Okay. We need to test it, even though I already told you, this is how we test it, right? So you take the angle you were given, so C1, sorry, C2 plus B is equal to 155.29 plus 20 degrees, which is 175, right? Which is less than 180. So since C1 plus B and C2 plus B are both less than 180, then we have two triangles. So this is the annoying situation. All right, so this goes here. So what is A1 given these two angles?
135.29.
135.29?
Yes, sir.
Yeah, cool. Yeah. Capital A?
Yes, sir.
And I'm sorry, capital A2, what's that one going to be?
4.71.
Yeah, so it's a small one, but it's just there. Small angle. So we're going to have to find another A, A1 and A2. I don't know why I put a 1 there. Okay. So real quick, let me get that picture out that we had earlier. Here it is. So this is what we have, right? We have two different C's. So it's going to open this way or that way. Okay, so C1, C2, which changes, sorry, they put their B here, I think. So B1, B2, C and C2 here changed. But notice the part that we're moving inward or outward doesn't change. Okay. Now, let's say you weren't sure which ones were fixed. Let's say, I don't know which ones are going to be whatever. You can try to, like, let's say, see how I told you that these will be the same, right? This B and C would be the same. If you didn't know that, if you're trying to solve for it, you're going to end up getting something that's exactly like this. So even if you're not sure, just try to solve it and you'll be fine. If you want to draw a triangle and try to visualize the two angles, then that's fine too. But I think it's easier to just try to solve for them, and it won't be too bad. But anyway, so let's say I thought there was a C1 and a C2, right? Suppose you didn't know. So you would equate, let me erase that. Pretend I don't know what that is. You would say C2 over sine C2 is equal to sine, or equal to B over sine B. So that means that C2 is equal to B sine C2 over sine B. So that will be 9 sine of 155.29 over sine of 20. So I bet you that's going to be 11. Let's see. Yeah, see how it's not exactly 11, but when you see this, you should automatically think, oh, you know what? That side is fixed. It's not C1, C2, they're the same. Oops, all blurry. Okay, so now let's find A2. So equate A2 to the same B thing. So that will be 9 sine of 4.71 over sine of 20. So 2.16. Any questions so far? Is it making sense or? Okay. The last one would be, I forgot about A1 out here, but you'll do the same thing you did here to switch these guys out. Here, I guess. Okay. So A1 over A sine A1 is equal to B over sine B. solve for A1. That was what? B was 9, right? Yeah. 9 sine 135.29 over sine of B20. So that should be 18.51. Alrighty. Any questions on this problem? You see how 2 triangles is not the scenario you want to do.
All I'm gonna say is thank God calculators have recall, like where you can just copy and paste what you just did.
Yeah, that'll be helpful. That's true. Before we had calculators, no, they had to use law of tangents for some of these hard problems. I think that was like, I don't know, 80 years ago or something, 100 years ago. I don't remember. Long time ago. 40s maybe?
Well, I had an engineer who's only like 29 tell me one of his calculus teachers wouldn't let him use calculators
For which class?
for one of his calculus classes,
I could see that.
that they wouldn't let him use calculators.
But
I was like, no.
for this class, you kind of have to have a scientific. There's no, either that or you have to leave it like this, there's no way you can do anything. But Cal 1, yeah, I could see that.
Math teachers are really cruel, sir.
Yeah, my Cal 1 and Cal 2 professors, they do not allow notes or calculators or anything. It sucked. It was just a pencil. Okay. So is this concept straightforward? Does it make sense?
Yes, sir.
Okay, let me just show you what the homework looks like before we move on to something else. So it starts off just fill in the blank, right? Testing if you know the law of sine. Who cares about that? Then you get to questions like this. And you have 2 angles and they give you a picture. So therefore you assume 1 triangle because you can see it, right? Same thing here. Yeah, so they gave me a picture. They gave me the angles. Who cares? But here, they only give me, where does it start? Oh, here it is, number 9. Number 9 is where it starts being weird. So they give you only 1 angle and 2 sides. So this is the scenario where you could have 2 angles. But when you try to solve for, let's say, capital B, you're going to get an error, which means there is no triangle. So you just write impossible. Or on a test, you can just say there is no triangle. You're done, because you can't solve for it. Okay, and this is something we just did right now. You have 2 sets of triangles. They just want you to organize it in a specific way. You use the bigger B here, whatever. Okay. They did not ask. Oh no, they did. Here's the side C. Cool. But yeah, just same thing over and over again. Just make sure you know how to check. I guess we'll stop there. You guys can start doing some questions for the exam or homework problems if you like. If you have no questions on 8.1.
I understand the algebra of 8.1, so long as I can use the calculator, I think I'm fine with that.
Alrighty. You guys have any homework questions or you want to do, or any concerns for on topics? Excuse me.
Probably, but nothing I can think of right now because I'm getting over a cold.
Let's see. Well, if you guys want to head out, you can. If you want to do some homework problems, let me know. No, I'll stick around for a bit.
You kind of give me, because I want to make sure that my calculator is not going to try to just power through this and give me some weird value.
Yeah.
Stupid things smarter than I am. Can we go through one that's an impossible?
Yeah, sure. Let's do it.
It's like just the part, not the. We don't have to go through all the rest of it.
Okay, let's do this one from the homework right here, number 9. So write down these guys. Example, what number are we on? 4. Okay, they give me A equal to 100. Little a is 175. Capital B is missing. Capital C is missing. Little b is 250. Okay. All right then. So obviously we should try to find capital B, right? Because we have its pair. We cannot mess with C currently. So we'll start by. What's up?
Sine over A equals, that's a B.
Yeah, either way.
Maybe we should start using the not C's.
The what?
Maybe they should start using D's and not C's because I can't tell the difference between my C's either.
Yeah, I know. I was like, maybe we could put like a little spike on it or something. Cool C. I don't know. Put a bar on top if you want. C bar. Okay, so multiply both sides by little b. So sine B is equal to B sine A over A, which implies that B is equal to sine inverse of all that nonsense. B sine A over A, which is sine inverse of, let's do it over here. $250 sine of 100 over 175. That looks like 1,000. So let's punch that in and see what happens. Sine inverse of, put it in fraction form, 250 sine 100. Make sure you're in degrees, 175 degrees, or whatever that is. And I get an error. There is no triangle.
Awesome. Yay.
Is that what you got?
Yep.
So you would just stop
Shows up
there.
Yeah. Yay.
Right. Do you have any other questions? I guess I'll see you Thursday. And if you have any review problems or homework problems you want to bring, I'll leave some time after class because I'm trying to go a little slower on each section since we still have plenty of time.
Can I just bitch for a minute? I'll just bitch if you're open to it.
No, I'm good. I'm good. Thanks.
Thanks, Tom.
Appreciate
Have a
the
good night.
offer. Have a good night.